we started with. Okay, so just so you know, remember the HMH stuff? We're going to be using that again. Okay, so I am at Unit 5. Please don't fall. You're really close. Okay, and 5.1 is just going to be transformations. Okay, so basically what we're going to do is we're going to take this function. Okay, so I'm going to call this my function f of x. Okay, that are included, and you just basically connect the dots. Okay, and we're going to take this and we're going to translate it. Huh? Yes. I know, it was all last period too. So I'm going to say that this point down here is A, this point is B, this one is going to be C, and this one is D. Okay, so just really quickly, what are the ordered pairs for these points? So what is A? -1, -2. What's B? 1, 2. What's C? 3, -2. And what's D? 5, 2. Okay, so when I listed this for my function, the input was the x value, right? And what was the output? Okay, so they're going to use the notation of f of x to represent the y value. Okay, you guys have seen f of x before, right? That's not new notation. You've seen it. Okay, good. Okay, so I'm going to kind of go back and forth between using their stuff and then kind of doing it my own way. So we're going to start by doing this right here, where we're going to add a k value, and we're going to specifically add a k value for, so maybe I should have circled that part instead. That would have made more sense. Okay, so if you think about the warm-up today, and if I have a +4 on the outside of any function, what direction does it take us? Up 4. Okay, so when it's on the outside and you add, it takes our function and moves it up 4 units. Okay, so I want to go back to this graph. And imagine that we're taking all of those points up 4 units. Okay, so what will my A point become if I move that 4 units up? So my A becomes -1, +2. What does my B become? 1, 6. What does the C become? 3, 2. And what about the D? 5, 6. I'll use a little prime so we can tell that those are moved. Okay, so this right here are the points f of x plus 4. Okay, so can you guys tell me what happened algebraically? So if we kind of don't even look at the graph and we go to the points, what did we do? Added 4 to what? To the y value. Okay, so think about this. Anytime you go up or down, you're doing something to the y value. Okay, so think the y value is up or down. So what kind of motion is this? Up or down? Vertical. A vertical motion. Okay, so I want you to understand that up or down is a vertical motion. Okay, and it affects what? The x or the y? And if I write y, everybody knows that it's the same as f of x, right? Those are interchangeable, right? Okay, so here's a big bubble of thought. Oh, interesting. Okay, so the next thing that they do is they ask us to now graph f of x minus 2. Okay, so if I have an x minus 2 inside parentheses, what direction is that going to go? To the right 2. Okay, so we know that this is going to go to the right 2 units. Okay, so let's go back to our little graph. Okay, and I'm going to do f of x minus 2. Okay, so looking at the graph, if you're looking at A and you're going to move that to the right 2 units, what does my new A point become? One, negative 2. What does my new B point become? I'll call it double prime. Okay, that goes 3, 2. Okay, can you start doing this just algebraically? What's happening? 5, negative 2. And what's my D going to be? 7, 2. Okay, so what just happened with my shift to the right? I added 2 to the x value. Okay, so when I moved left and right, okay, left and right, what kind of shift is that? Horizontal, right? So if I have a left or right, that's a horizontal motion or shift, I guess you could say. Whoops, I don't know how to show. We'll keep it consistent. Okay, so when I moved horizontally, which variable did it affect? The x value. So it affected, oh my gosh, 2. Okay. So, do you think I need to do an example of like another one of these? So like if I had x plus 5 inside parentheses, I don't need to say what direction that moves. Everybody understands how to do that with points and stuff? Okay. The ceiling. Sorry, I know. Nobody even noticed it last period, and then I was like, gosh, that is so annoying, and then they all noticed. And that was pretty much the end of that. Okay, so let's talk about having a value that's in front. Okay, so I did our warm-up today like this. Okay, so if I put a 2 in front of the F, okay, I kind of like their table this time because now I can just kind of place it right in there. Okay, what is happening in the table? Which value is being multiplied by 2? The F one or the Y, right? Okay, so if I finished figuring or filling out this table, I'd have -4, +4. Okay, so my new ordered pairs, my A would become -1, -4. My B would become 1, 4. My C is becoming 3, -4. And my D is 5, 4. Okay, so remember this is multiplying by 2. Okay, so when we were thinking about the parabola, we said, oh, it just made the parabola, what did it do? Skinnier, right? It did like a compression, right? Okay, so is that going to be the same thing that happens here? Okay, so watch the points as I graph them. Watch what happens. Okay, so I have -1, -4, 1, 4, 3, -4, 5, 4. Okay, so I'll just kind of connect the dots so you can see this. Okay, so what happened? How would you describe this? It kind of got skinnier, right? But the way I want you guys to think of it is, you guys know that, what's that instrument that you play that goes? Accordion. Okay, the accordion, right? Okay, so imagine like an accordion. Okay, so you can do it vertically and you can do it horizontally. Okay, so on an accordion, this is I'm holding this like vertically, right? So I have a vertical, what? Like stretch, right? Expansion, whatever you want to call it. Okay, so what happens when I multiply by 2, It basically makes the height of whatever which value am I talking about? My height. My y goes twice as far from the x-axis. See what I'm saying? Okay, so if I had a y value of 5 and I wanted to multiply by 3, what would my new y value become? 15, so I'd pull it even further. Okay, so multiplying by a number pulls it out. How would I make it go inwards and squeeze it towards the x-axis? Multiply by a negative? By a decimal. It'd be kind of like dividing, right? Okay, so we can think of it two ways. You can say, oh, okay, I'm dividing by a number, or you can say I'm multiplying by a fraction, right? As long as the fraction exists between 0 and 1. Okay, so this is what we're going to write for notes on this. So 2 f of x resulted, okay, this was a vertical, hold on, I'm really bad at spelling right now today. Vertical, I'm going to call that vertical stretch, right? Would you call that a stretch if you're pulling it away? Stretch. Okay, so what happened, like algebraically, it affected which variable? The y variable, and I just multiplied by whatever the expansion was. Multiplied y by 2. Okay, so if I wanted to make something shrink, squeeze it down, give me an example. What number could I multiply by? 0.5. Or can I use 1/2 because I like fractions? Okay, so 1/2 or some kind of fraction, right? So maybe give yourself a note like, if this is 0, we'll call it a, and 1. That number has to be between there. Okay, so we're still talking about vertical. Okay, what word would you say to squeeze it down? Vertical compression? Okay, and how did we find the new y value if we found it? Just multiply by 1/2, right? So I would multiply the y by 1/2, so it's half as high. Okay, so make sure I would like highlight the y value. Okay, so remember anything vertically is y, right? Affects the y. Up and down, vertically. Outside the parentheses, it's vertical. Okay, so how would we make it go this way? So if I turned it and talked about horizontal compression, or what's the opposite of compression? Expression. No, that's not right. That sounds cool though. Expansion. Expansion, right? Okay, so how would I do something that way? Affect the x, right? So how would I do that, like notation-wise, with my f of x? F of x and then the 2? Like, okay, so think about, to move the function left and right, we had to add or subtract inside the parentheses.
Yeah, 2 inside the parentheses.
Okay, so if I put a 2 inside the parentheses, let's see what happens. Let's try that. Okay, so let's do, oh, they don't do this example. Let's do our own example. That's silly. I can't believe they're doing that. Okay, so let's do, we're going to have our g of x be f of 2x, right? Okay, so what were our points again? We had, you guys, anybody write them down? Oh, I have them right here. Let's see, -1, -2, b, oh wait, let's do it as a table so it makes more sense, right? I got this. Stay with me. So we had the x and we had the f of x. That's how they did that table. I kind of like the way they did that. So it was -1, -2. And then b was 1, 2. And then C was 3, negative 2. And D was 5, 2. Everybody follow that, my little table? So if it helps you do this. That looks good. Okay, so what's going to happen this time if we do f of 2x? So how are we going to do this? Which one are we going to multiply by 2? That is the best I've ever drawn. It's beautiful. So which one am I going to multiply by 2? The x or the y's? The x's. This time we're going to multiply the x's by 2. Okay? That's what you meant. So, okay, so if we multiply the x by 2, this is going to become, let me draw it in a different color. It'll become negative 2, 2, 6, and 10, right? Okay, so let's see what happens. So my new A point becomes, so notice that this red one is my new x. So negative 2, negative 2, 2, 2, 6, negative 2, 10, 2. Okay, so here's my little thingy right here. So I'm going to go negative 2, negative 2, 2, 2. 6, negative 2. Uh-oh. 10, 2. Yeah. So what happened?
Expanded.
Stretched it like horizontally, right? Affected. Which variable did it affect? The x. Okay, so bottom line of this. Stuff that happens on the outside affects what? Okay, up and down your y. And stuff that happens on the inside affects the x. Okay. Expand. Horizontal expansion. You know what I meant. Okay. So the next thing they talk about is reflections. Okay, so we kind of talked about this when we did our quadratics. What happens if you have a negative out in front of a function? Okay, so if I have like negative x squared, what happens to my parabola? It gets flipped upside down. Okay, so instead of saying it gets flipped upside down, we need to say it like more technically. It gets reflected across the x-axis. Okay, so do I really like need to do these points and plot them and so you can see it? Can everybody be okay that if I put a negative in front, we can just say reflects across x-axis. Okay, so how do you reflect across the y? In the parentheses. Oh, you guys are so smart. Negative on the inside reflects, oops, gosh, I'm just not having a good day of writing. Across the y-axis. Okay. That's pretty easy. And you guys are all understanding like what reflecting over the y-axis is? Okay. Okay, that was pretty fast. All right. Done and done, done and done. Let's see. Okay, so this is something that they're going to do is they're going to give you like this, and then they'll give you like the graph of this and say which one of these is right. Okay, so here, let me write this over here so you can see what that means. Let's do this one. I'm just going to tell you what do we got? -3, -3 f of x minus 2. What is that? Minus 4. Okay, so just by looking at this notation, okay, first of all, if we know f of x is x squared, we're talking about what kind of a function? What does x squared look like if I just graph that? Parabola, right? Goes right through the origin, right at 0, 0. Okay, so if I'm graphing the g of x, describe the transformation. What does the minus 4 at the end of the graph do? What direction? Down 4. Okay, so it's going to go down 4. Good, so inside right 2. Okay, what is the 3? Ignore the negative for a second. What's just the 3 going to do? Skinnier. Okay, so let's say vertical or horizontal? Vertically, because it's on the outside. And is it going to pull it away? Stretch or compression? Stretch. Good. So vertical, vert. Okay, and what is the negative out in front going to do? Flip it upside down. So I'm going to say reflect over x. Perfect. Okay, so you just kind of figure out which one looks like that.
It's not always with the x-axis.
Yep, it is always.
What if it's like, isn't it down 4?
Yeah.
So like,
Well,
that negative.
yeah, so you would like flip it upside first. So the idea is that you would have a parabola that's upside down. So the reflection across the x-axis happens first, and then you would do your translations. So that's actually okay. So there's 2 other things that they talk about in this, and they just assume that you knew this previously. So I assume that you didn't know this. Does anybody know what an even, odd, or neither function is? Okay. That one? Which one? C?
Right one.
It is, you're right. Let me give you the definition of them. So I would write this down. You'll see this again, just so you know. Even function.
It's like symmetrical.
Mm-hmm. Okay, so an even function is symmetrical over the y-axis. Okay, so like a parabola is symmetrical over the y-axis as long as the vertex is on the y-axis, right? To move to the right or to the left, it's not. Okay. The other way to think about this is to think about it, we've kind of been talking about it with points, right? Okay, so let's say if this is point, that looks like 2, 5. Okay, what would this point that's on the exact other side be? Negative 2, 5. Okay, so if we were going to write some notation for this, that would mean if I have a negative x value, it would be the same as if I have a positive x value. Okay, so see how they both come out to 5, the 5 stays the same? It doesn't matter if the x values are both negative, the y value comes out the same. Positive or negative. Okay, so an odd function . Anybody ever heard of symmetrical over the origin?
It's almost 0, 0.
It is not the x-axis.
0, 0.
It has to go through, well, it doesn't always have to go through 0, 0, but the idea of some symmetrical over the origin, there's not like a line that is the origin line. Okay, it is a point. So the idea is like if you take the function and you turn it upside down, it would look exactly the same. Okay, so like, so something that was like this. Okay, so if this was point, well, let's just use 2, 5 again. What would this point down here have to be? -2, -5. Okay, so the idea is that the x and the y are just exactly opposite. Okay, so see how like if you turn this function exactly upside down, it would look exactly the same? It's hard to kind of imagine. Okay, but this arm would still be going up at the same angle. Okay, going through the origin is not always necessary, but it helps. Okay, so just so you know, the notation for this would be if you plug in a -x, you get out a -y. Okay, so they'll kind of ask you to do that with points and just give you a function. Okay, so now that you know what an even and odd function is, for A, B, and C, which of them is even? Which one is even?
Middle one.
Middle one, symmetrical over the y. So B is even. So which one is odd?
A.
A, very good. So this one is odd. Okay, so everything else, if it's none of those, then that's a neither. Okay.
Oh, yeah, that's why.
Okay. All right, so that should be enough information for you to complete